We are given this definite integral from 0 to pi over 4 of negative 10 cos squared theta tan squared theta d theta. Now, if we look at this, we can see that our integral is expressed in terms of cosine functions and tangent functions, and they're both trigonometric functions, so we might be tempted to start doing maybe substitutions or integration by parts, but it's good to think back to the trigonometric identities, and just from looking at this, we can see that tangent theta is in fact sine theta over cosine theta. So if we have tangent squared theta, then we can rewrite this integral as, that's pi over 4. We can rewrite this integral as negative 10 cosine squared theta sine squared theta over cosine squared theta. So now these cosine squared thetas can cancel out, and we have a much more simple integral to compute. So if we keep going, then what we are going to get is negative 10 sine squared theta d theta. And now if we recall our double angle formula, we know that cosine 2 theta equals cosine squared theta minus sine squared theta. And if we rearrange this in terms of sine squared theta, or if we plug in our Pythagorean identity, which is sine squared theta plus cos squared theta equals 1, then what we get is sine squared theta equals 1/2 of 1 minus cosine 2 theta. So we can plug this in to here. So this is going to be slightly easier than having to deal with sine squares, because now we can deal with just a cosine 2 theta. So if we do that, we are going to get the integral from 0 to pi over 4 of negative 10, and here we have times 1/2 1 minus cosine 2 theta d theta. Now if we just continue distributing, so this negative 10 times 1/2 is just going to give us a negative 5. So we can take that outside of the integral. So we have negative 5 times the definite integral of 1 minus cosine 2 theta d theta. So if we compute the antiderivative of this, we get theta minus 1/2 sine 2 theta. And this is evaluated at pi over 4 and 0. So right now we can plug in these values into our antiderivatives, and what we are going to get, if we plug in pi over 4 into theta, it's just pi over 4 minus 1/2 of sine 2 times pi over 4, so that's just going to be sine pi over 2. And this is going to minus this thing evaluated at 0. So theta equals 0, well that's just 0, minus 1/2 sine times 2 theta, 2 times 0 is 0, sine 0 is 0, so it's just all 0 for the second part, so that's easy. Now we can simplify this farther, so we get negative 5 times pi over 4 minus 1/2 times sine pi over 2. Now sine pi over 2 is just 1. So here we have 1/2. So if we rewrite this and distribute the negative 5, we get 5 over 2 minus 5 pi over 4. Now that is the result of this definite integral.